Hello, my dear students. Hello, my dear students. Welcome to my YouTube channel, New Academy of Mathematics. So in today's lecture, I am going to discuss about the gradient of a scalar. In the last video, I just give the basic definition of this gradient, and today I am going to discuss some important problems related to this topic. So just look at the screen. First problem I have taken. If r equal to xi cap plus yj plus zk, then what we have to show gradient of r to the power n equal to n r to the power n minus 2 into vector. So dear students, when we have to solve the problems based on this vector r, the first step always you follow is what you compute the magnitude of r. आप लोग जब आपको वेक्टर आर से रिलेटेड इस तरह से ग्रेडियंट डाइवर्जेंस या कर्ल की कोई भी प्रॉब्लम दी जाएगी तो आप क्या करेंगे, तो उसका मैग्नीट्यूड निकालेंगे. तो मैग्नीट्यूड ऑफ आर क्या आएगा? इट इज अंडर रूट स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर, एंड व्हाट यू राइट इट एज दिस स्केलर आर. So magnitude of r is this scalar r, and you are getting this under root x square plus y square plus. So in the next step, what we do, we square both sides. This is the second step. We square both sides, so you get this equation number 1, r square equal to x square plus y square plus. So in the first step, we are taking the magnitude, then we are squaring, and in the next step, we differentiate both sides of one partially with respect to x, then with respect to y, then with respect to z. But you have to differentiate with respect to only one variable, and other two values you will get from the same. So when we differentiate this one both sides partially with respect to x, so what we get, derivative of this r square with respect to x is what? R square is 2r. Then we apply the chain rule because r is also a function of x. So we get it as 2r del r by del. And in the right side, derivative of x square is 2x because y and z are constants. So derivative of y square as well as derivative of z square is 0. So you get this as 2. So finally, this 2 will cancel out from both sides. So you get r del r by del x equal to. So finally, you are getting the value of del r by del x as by r. So similarly, we can find the value of this del r by del I y as y by r, and del r by del z as z by r. So keep in mind these three values. If you solve del r by del x, so it is getting in the reverse, that is x by r. If you are computing del r by del y, you are getting r, del r by del z. So we have to make use of these three values. इन three values का हमें use करना है. तो अब जैसे प्रॉब्लम आपको दी गई, the problem which is given, we have to find or compute or to prove this del Rn equal to n r to the power n minus 2 into vector r. So you know the value of this del, just I discussed in the previous video also. This del is known as, you say, gradient or nebula, and the value of this del operator is y what I del by del x plus j del by del y plus. So we put the value of this del and we operate this del on this r to the power n because it is an operator. So we operate it on this r to the power n. So I cap curl by curl x r to the power n plus j cap curl by curl y r to the power n plus k cap curl by curl z. In short form also you can write it as sigma I cap del by del x of r to the power n. So I will solve some problems from this method also, this compact form, and this is the expanded form. means to say in which we are taking all the variables, right? So we solve one by one. Del by del x of r की power n is n r to the power n minus 1 del r by del x. Similarly, del by del y of r to the power n is n r to the power n 1 del r by del y. Similarly, we will compute the value for z. And you can look at here, we can take out common this n r to the power n minus 1. And inside this, you will get I cap del r by del x plus j cap del r by del y plus k cap del. And when we put the value of this del r by del x, del r by del y, del r by del from the previous slide, you can look del r by del x is r, and so we put the value of del r by del x here, x by r, del r by del y r, del r by del r. So again we take this 1 by r common, so you get an r to the power n minus 1 by r, and it is xi cap plus yj cap plus z cap, whose value is this vector r. So you get this answer grade of r की power n, or what you say del of r की n equal to n r to the power. So this is one of the very important problem generally asked in the final exam. So UG vector calculus. So I have taken two questions based on this same problem. Rather, you can solve this question as well as this question directly, or you can make use of this previous question also. Just like in this question, you have to show grade RO equal to vector R by R. So if you compare this grade R with this problem grade R KN, so difference is what we put here n equal to 1. So when we put n equal to 1, so you get here 1 r to the power 1 minus 2 into vector R. It is 1 r to the power 1 minus 2 into vector R. R to the power 1 minus 2 is R inverse. That's why it is R by R. This is the answer. So you can solve it directly also. In place of this R to the power n, everywhere you will just keep R and you will get the answer. Similarly, if you, in the next question, if you have to find gradient of 1 by R, or you say del 1 by R, so again you compare this del of 1 by R, or rather you say del R inverse. So in this, again you put in this 2 equal to minus 1. I have written here, put n equal to minus 1. So when we put n equal to minus 1 and 2, so you get grade of R inverse equal to value of n is minus 1. So minus 1 R to the power minus 1 minus R. Finally, you get the answer R by R. So you can solve many problems. You can get R to the power also, and rather the positive power also. So the method is same. So come to the next slide. In next slide also I have solved some problems already. Just like in this problem, you have to show del of fr equal to f dash r into del r. F dash r into del r. So again, we have to just use the formula del fr equal to I cap del by del x fr plus j cap del by del y fr plus f del by del z. So I have solved this problem by this method. You can write it as sigma I cap del by del x of fr, which I have shown. R is xi plus y plus yj plus zk. Then you can write it as sigma xi cap, but you can write sigma yj cap or the sigma z. You have to take only one value in this compact form. So I have taken this derivative with respect to x is I cap curl by curl x. Again, I am saying you can keep it as curl by curl y or curl by curl z, but you have to keep only one term. So after that we solve. We differentiate this f r with respect to x. I have shown here that this f is a composite function of x. F is a composite function of y composite because f is depending on r is depending on x. F is composite function of x. So in that case, we apply the chain rule. First of all, we differentiate f with respect to r. That's why we are getting it as f dash r. Suppose f is depending on a single variable, that's we have taken it as prime, that is the total derivative. But this r is depending on x, y, z, that's why we are in this partial derivative. So you get f dash r del r by del x. Again, put the value of del r by del x, which is x by r. So we keep this f dash r by r outside, and we are getting f dash r by r sigma xi cap. Value of this sigma xi cap we have written here. Sigma xi cap is equal to this vector r. You put the value of this sigma xi cap as r. So you get the answer f dash r into vector r by r. So you get one answer, but because you have asked the answer in the form of gradient r in the right side, so this is nothing. This vector r by r is what? Gradient of r. Gradient of r. Because in the previous you have written gradient of r equal to r by r. The question number 2. So I have taken one more simple problem that you have to find del of log r. Where you have to show it is r by r sphere. Problem is very simple. Again, you take del log r equal to I cap curl by curl x r. Differentiate this log r with respect to x. So derivative of log r is 1 by r del r by del x. And del r by del x is nothing, it is x by r. It is x. So again you take 1 by r square outside. Is again I cap. Value is with this. So hope so you understand all these problems. Sorry. Based on this gradient. In the next videos, I will discuss directional derivative of a scalar function in the direction of a unit vector. So keep watching our YouTube channel, Shiv Academy of Mathematics, and don't forget to subscribe our YouTube channel, Shiv Academy of Mathematics. Thanks for watching the videos. Have a good day.